Hey, this is Jason Molesky. In this example, we'll take a look at performing some calculations using the central limit theorem. Suppose your company has a contract to perform preventative maintenance on thousands of air conditioning units in a large city. Now, based on service records from the past year, the time that a technician requires to complete the work follows a strongly right-skewed distribution with a mean of 1 hour and a standard deviation of 1 hour. In the coming week, your company has to service a simple random sample of 70 air conditioning units in the city. You plan to budget an average of 1.1 hours per unit for a technician to complete the work. Will this be enough? So our problem is to figure out what the probability is that the average maintenance time, x bar, for 70 units exceeds 1.1 hours. For step 1, let's state the distribution and values of interest. Now the sampling distribution of the sample mean time, x bar, spent working on these 70 units has a mean equal to the mean of the population, or 1 hour, and a standard deviation equal to the population standard deviation divided by the square root of 70, our sample size, or 0.12. Now we can do this because the 10% condition is met. We figure there's more than 700 air conditioning units in the population. Since the normal condition is met, that is, since our sample size 70 is greater than or equal to 30, we know that our sampling distribution of x bar is going to be approximately normal, even though we've got a right-skewed distribution in the population. Again, that's because 70 is greater than 30. We've got a sample size great enough to ensure that our sampling distribution will be approximately normal. So we want to find the probability that x bar is going to be greater than 1.1. We'll first need to find the standardized score for our boundary value. 1.1 minus 1 over our standard deviation of 0.12 gives us a boundary value of 0.83. Using table A, we can find our probability. 1 minus 0.7967 gives us a probability of 0.2033. So to answer the question, if we budget 1.1 hours per unit, there's about a 20% chance that the technicians will not complete the work within the budgeted time. You'll have to decide if this risk is worth taking or if you should decide to schedule more time for the work. Now for some additional practice in doing calculations using the central limit theorem, try exercise 63.